the previous videos, we mentioned about the considerations which you need to take into account when you do the analysis and design of RC structures. There will be two main parts. One is from the theoretical aspects, another one is from the practical aspects. In terms of the theoretical aspect, most of them will be covered in the lecture when you undertake the course Reinforced Concrete Design. There will be a lot of references specifically for the Reinforced Concrete Design as well, and you have quite established standards such as Eurocode and BS. We see most of the cases as the students go along with the course. Normally, students have no significant problem with the theoretical aspects. However, there is another aspect that you need to consider, which is the practical aspects. You need to be familiar with the local practices, and this requires the exposures to the practices in the industry, which normally students at this stage are yet to be involved with the industrial trainings. Most of the practices in the industries, the students learn from what the lecturer have shared. However, those knowledge are as a part and parcel of the lecture. Sometimes it is not systematically and clearly stated their correlations in your design. I believe this is the main problem when students design for the RC assignment. A lot of solutions may not seem to be practical. So far, we have covered quite a number of the practical considerations. You know that the local industries are still heavily dependent on the imperial system. You know that the functions of the structural drawing is to make clear to the contractor without requiring your clarifications. They know how to construct it. You know that there are a lot of practical problems when you actually do the works on site. You realize that there are certain designs which are technically viable but not necessarily practical on site. All this you're supposed to take into considerations to make you a good designer. The main reason of this is different parties are actually working on the same project, only they cover different parts. It is only when there is a good collaborations and cooperations among the parties, the project can be properly realized. No matter how good is your technical design, if it is difficult to be constructed on site, there is still chances for you to have problem with the final outcome of the structures. The quality may be questionable, and there could be undesired defects, which leads to redistributions of the stresses and load in the manner that you did not consider during the design stage. And this could lead to the problem with the integrity and the stability of the structures. You need to also aware about the common sizes of the steel bar in the industry. This is also a common mistake by the students, not aware of those, proposing certain size of the reinforcement bar which cannot be found in the industry, or using certain sizes which is not commonly used in the industry. There is a reason of certain popularity of some materials. As the local industry has been operated for so long, they are now reaching to a state which is rather established, optimized, and quite difficult to change, unless there are new evolution technology imposed into the industry. As long as it is still the conventional methods of constructions for the reinforced concrete structures, most likely what is commonly practiced in the industry will still apply. And if you compare the designers in the industry, most of the designers will give you more or less similar outcomes. That means they have already adapted with the cultures and the application in the industry. The faster you adapt with the common applications with the local industry, as long as it doesn't compromise in terms of the technical aspects, the better you will do in the industry. We also mentioned about the considerations related to the piles. It is not just only knowing the size, as well as knowing the working loads. You will have to consider from various aspects. As we have discussed in the previous videos, the ultimate goal here is to fulfill the requirement in terms of the technical aspect, which at the same time, the solutions need to be practical. You need to find a balance in between the practical and economical solutions. You cannot make your design to be extremely practical, which leads to the hiking of the construction costs. In this case, the other designer will be able to produce a more economical solutions with more or less degree of the practicalness. You also cannot go for extremely economical, but the solutions are not practical at all. This will lead to the situation that the project is difficult to be managed on site. There will be additional costs incurred, which may not directly or immediately associated with the cost of the construction, such as the difficulties of completing the project on time, such as they require workers of higher levels of expertise. Of course, at the end of the day, this kind of problem will also evolve into the cost matter, that you thought your design is to be extremely economical. The economical, it will be on the material aspects, which you not realize that there will be other areas such as the workers, such as the machineries, as well as the time allocated for the supervisions and monitoring. This may lead to hiking of the costs other than the material costs. All this need to be taken into considerations. The point here is you need to find a balance in between the economic usage of the material as well as the practical considerations. It is so that the project can smoothly being executed. Now we're going to proceed our discussions on the other practical aspects, which is also important for you to consider during your design. First, for the purpose of the applications, imagine that the site personnel, when the buildings is being constructed, it cannot be done alone. Even within the contractors, there are workers, and these workers have their own expertise as well. Some are general workers, they deal with the concrete. Some are the steel workers, they deal with the reinforcement bars. They bend the reinforcement bar, they tie the reinforcement bar. They know how to read the detailings of the structures. And there will be timber worker. They produce the formworks. It is another specialized task among the workers. Based on the dimensions given in the technical drawing, they know that how they're supposed to construct the formworks for the placement of the reinforcement bar, and then get ready for the casting of the concrete without any leakage, without any undesired deformations of the formworks that can result in different shapes and size of the structural elements. That is not all. The site supervisor, let's say the head of the contractor, will need to supervise the entire project, ensure they are doing in the right way, complying to the detailings given by the engineers. Which at the same time, there will be site engineers, which can come from the main con or the subcontractor that themselves has their own site engineers. This one is to cover the technical aspects, which in most of the cases, dealing with the detailings of the structural element, the grade of the materials, the right materials being used, the quality of the materials, as well as the quality of the outcome. You know that working in the site, many things can go wrong. As for us as a designer, everything are on sketch. It is very easy to draw a straight line. However, in the construction site, there will be a lot of preparations as well as temporary works in order to ensure everything are constructed accordingly. And then there will be checking from the consultant, ensure the site personnel are doing the job in accordance to their drawing. In the case that certain things cannot be properly done on site, it is either for them to reject or to propose alternative for the solutions, and so on so forth. What you see here, the entire project here involves so many parties, some at the ground level, some at the higher up in terms of the decision level, and some at the approval levels. There will be constant monitoring as a part of the supervisions to ensure the quality of the structures. And this comes to a situation that you cannot allow too much variety in terms of the design throughout the entire building. You cannot expect the person doing the supervisions on site have to flip through the technical drawing every single second, use the measuring tape, measure every single place to ensure everything's are just precisely the same as indicated in the technical drawing. This is going to make the checking process to be very non-productive. What you can do here is you will need to limit the numbers of the sizes to be applied throughout the entire building. This is so that the checking can be done quickly. Some require measurements, some can be quickly observed through visual inspections. Now that you know the reason behind it, we're going to look into every single part of it. Try to standardize the thickness of the slab for all floors to avoid confusions. Let's say now you decided the slab to be 125, or if you have larger slab, probably 150, or if you have the slab much more larger, probably 175. The bottom line here is you make sure every floor the size of the slab are more or less the same. That one is for the economical aspects, and you make sure all the floors have the similar thickness in terms of the slab. This one is for the consistency as well as for the practical aspects. This will prevent the problem that somebody or somewhere in the pipeline overlook the changing numbers in terms of the thickness of the slab, assuming every floor having the same thickness as typically design engineer will do, which just happened to your case. You have different thickness at different floor. This going to lead to the complications in terms of the delivery of the structures. Next, you will need to use some common sizes of the beam, columns, and foundations. And those sizes, if possible, it should be something which is commonly seen in the construction industry. Because if you are talking about the standard size mostly applied in the construction industry, it is very easy for them to remember, monitor, and with sufficient experience, just by looking at the members, they will know more or less the size is accurate. This is something interesting, especially for us that do not have sufficient exposure to the industry. You will see the engineers and the contractor just by visually looking at the steel bar without doing any measurements. They know that the size of the steel bars. And there are many contractors as well as the site engineers, by looking at the column itself or the ceilings, they will know that whether the column is vertically aligned or whether the walls is straightly aligned. All this require experience. They have their own ways to do it. This will need to be learned from the industries. All these are the soft skills required in the industry. Sometimes they need to plan their work ahead. For example, for the pouring concrete process, it is not as easy as we imagine. You ask for the ready-mix concrete to come. Now the concrete mixer come ready, and you expect the concrete will be properly placed onto the structural element for the casting. This normally will not do. You need to plan the work path as well as the workflow together with the traffic for you to mobilize the concrete from the concrete mixer onto the structural element. You know that the ground conditions are soft because you haven't finished the construction. You will need to make sure those soft soil is able to carry weight, that the entire workflow is smooth, and you know that the concrete have their own setting time, which within 45 minutes and 1 hour, they should have already properly placed and leveled for sufficient workabilities. All these need to be properly planned. It is not as easy as you think. It is always a good practice of you when you design your structures. Think about how the work is being done, as well as pay respect for the workers for all the difficult job that they have to deal with in their efforts to fulfill our requirements. It is only when you really consider their needs on site you can incorporate this kind of respect in your design, and then the efficiency of the work as well as the quality of the workmanship can be ensured. Next, we talk about the thickness of the staircase. If possible, you make the staircase to be more or less the same size in terms of the thickness. There could be more than one staircase, and these staircases are connected from a floor to another floor. Maybe you just standardize the thickness of the staircase and make minor adjustment in terms of the amount of reinforcement bar, which normally the steel workers will look into that. Again, you have to consider the fire resistance rating between the structural element. This was a mistake from my students, that some elements have the fire rating of 90 minutes, while some others have the fire rating of 120 minutes. It needs to be consistent, and probably you might need to check the requirements from the bomba, which is the firefighting department, from the local, to see if there are any stated requirements in terms of the fire resistance rating. I believe it should be somewhere between 90 minutes and 120 minutes, and make it consistent throughout. This fire resistance rating, ultimately it will influence the concrete cover that you use in the structural elements.